So if you look at the top function, you can tell the horizontal asymptote and vertical asymptote pretty easily. Okay, so what's the vertical asymptote in this case? What's the vertical asymptote for this function? Vertical asymptote. X equals to 0. Because when we think about vertical asymptote, we think of the word undefined, right? And what makes the function undefined? What makes this fraction undefined is when the denominator equal to 0. Okay. Now, with that said and drawn, so the vertical asymptote happens to be on the y-axis. What else can we tell if it happens at the y-axis? If the vertical asymptote happens on the y-axis, there's no y-intercept. There's no way for it to have any y-intercepts because the graph would not touch or cross the y-axis. Okay? And then we think about, what about the horizontal asymptote? What did we say yesterday? When you think of horizontal asymptote, what must be the thought process? What becomes infinity? The x. Because we're looking at, as we go all the way to the right, okay, which means x going to infinity, where would the graph approach to? Okay, that's the thought process. That's what we are curious about. As we zoom to the right-hand side of the graph, what is the y value? So you think about, let me think about this, all right? X squared minus 1 over x squared. Would the minus 1 matter when x is so huge? It wouldn't matter. So that means you can reduce it to just x squared over x squared, which is 1. So y value, it's equal to 1. That would be our horizontal asymptote. Now, I would guarantee you one thing, and that is if you are just thinking about, how to find out these asymptotes, and you never open your mouth and speak actual words to describe it, you're going to lose it. I guarantee you. Okay? Now, let's go ahead and find out the x-intercept. And for x-intercept, we will set the whole fraction equal to 0, right? And for a fraction to equal to 0, what must be 0? The what? The numerator or the denominator? For a fraction to be 0, the numerator must be 0. Because if the denominator becomes 0, what's going to happen? Undefined, right? So if you want to have a fraction that results in 0, your numerator has to be 0. And when you look at the numerator, can you see anything special with the numerator? What can you do with the numerator? What can you do with the numerator? I hope you are seeing this. I hope you're thinking about factoring. What would it factor into? X plus 1, x minus 1. Okay, that should be automatic. And again, for a fraction to be 0, what has to be 0 again? The numerator. Okay, so one thing that should come out of this unit is that you should know more about fractions. Numerator be 0, fraction becomes 0. The denominator becomes 0, the whole fraction becomes undefined. Okay, I hope you become a pro in interpreting these scenarios. So that means x plus 1 is equal to 0, x minus 1 is equal to 0. Therefore, x is equal to -1 and x is equal to 1. So we actually have two x-intercepts. We have -1 comma 0 and 1 comma 0. Okay. So let's go ahead and plot these 2 points over here. Okay. Plot these 2 points over here. And now we are about to draw our graph, but before we draw it, I want to make sure that you are fully aware of a feature. And that feature, you may want to circle it or highlight it. The feature is right here. It's in the denominator, and it is, oops, it is being squared. Okay? The denominator is x, and it is being squared. Now, I think you know one thing about something being squared. If anything being squared, what can you say about the value? If anything being squared, the value must be? It's always positive, or maybe at least as small as 0, but it cannot be negative, right? So now, so what it means over here when there is a square in the denominators. First, whenever there's a square, we can interpret this as there's no sign change. Okay, so whether you have x being positive number, x being negative number, you still end up with the same positive number, so there's no sign change. And how does this no sign change influence our graph, especially our vertical asymptote? Well, because there's no sign change, it goes like this. Okay, so yesterday we didn't see the square, so therefore when you draw the graph right near the vertical asymptotes, they were always in opposite directions. But because of this particular square, there is no sign change. So both sides of the graph would head towards the same direction. So that's how you know. Okay, that's how you know they would head to the same direction. Okay, and they're both going down in this case. Okay, they're both going down in this case. And if I may catch your attention right here, so we're gonna see, we're gonna put some, make some drawings on the next page. So if you could turn to the next page and look at the middle part of the next page, okay? This part right here. So the so-called multiplicity is basically the power of all these factors. So if it is a single multiplicity, like what we did yesterday, that is what we say with sign changes. So the graph that we drew yesterday was like this, and this right next to the vertical asymptotes. You see how it goes to a positive n and a negative n on either side of the vertical asymptote. The other variant could be like this or this. Okay. So they go in opposite directions if it's not squared. But if it is squared, then we will see something that we saw just now. It could either be both heading to the positive direction, or both heading to negative direction. Okay, so that's the meaning of having a square, is that there is no sign change. Okay, this one is no sign change because it's being squared. So therefore, they both head to the same direction. All right, now to show you an example, if you could turn to the worksheet page. If you can turn to the worksheet page and look at question number 3. Okay, if you could turn to the worksheet page, question number 3, right here. And then I want you to take a look at it. Okay, I want you to take a look at it, and then you can see how this whole square thing could be visualized, and you can see how it's being applied into a real example.